Hello and welcome to the third section of the course, the section Exploratory Data Analysis. In this section, we will learn techniques available in Sprk for exploratory data analysis involves asking questions about the data and receiving answers to them by the means of visualizations and statistical metrics. This allows researchers to have an idea of the direction in which they should develop their models. This section consists of two parts. In the first part, we will see what tools are available in SprkNotbuk for data visualization. In the second part, we will see what Sprk has to offer in terms of statistical functions. Let us now get started with the visualization tools offered by SprkNotbuk. SprkNotbuk supports a variety of widgets for data visualization. Different widgets are applicable in different scenarios, but you use all of them in the same way. In this video, we shall see how to use the widgets in case of the houses prices data. In fact, we have already seen one such widget, the table chart. In the previous videos, we saw how it can display any kind of collection as a table. In this video, we will see some other widgets, the line chart, the pie chart, and the radar chart. Before we move to the practical part of this video, let us briefly remember what our dataset was all about. First of all, it contains the properties of the houses in the variables of two kinds. First of all, these are the categorical variables represented as strings, and secondly, these are scalar variables represented as integers. Some examples of categorical variables can be the type of the street the property has access to. These are gravel streets or paved streets. The type of the alley the property has access to, also gravel, paved, or no alley access. The lot shape, general shape of the property, regular, slightly irregular, moderate irregular, or totally irregular. And also the other kind of variables that is accessible for us is scalar or integer variables, and some examples of these are the year in which the property was built, the area of the property, etc. The objective in this dataset competition is to predict the price of the house based on its properties. Overall, the dataset contains dozens of such variables, and the detailed description of each variable can be obtained from Kaggle, from the page where we downloaded the data. I have already prepared a notebook that initializes the environment and loads the data as was described in the previous section. Notice that in this video we will be using some basic statistical functions, such as an average of a column. This is why I have imported the statistical functions of Sprk. I have done so using this import. First chart we are going to discuss is the line chart. A line chart displays information as a series of data points connected by straight line segments. It can be used to display one variable as a function of another. Let us see how it can be applied to our dataset. Exploratory data analysis involves a researcher asking relevant questions about their dataset. If our goal is to predict the final price of a house based on its characteristics, one interesting question we can ask is whether there is a correlation between the year a house was built in and its price. We can visualize the answer to this question by plotting the average price of all the houses built in a certain year against the year they were built in. First, we need to prepare the data we are going to visualize, the years and the averages of the prices. We can do so in two steps. First, we need to group the data by year. Then, we need to turn each year into a dataset row containing the year built column and the average price column. First, we can group the data by year with the help of group by function as follows. This results in an object of type relational group dataset. It represents a dataset grouped by a certain column and has a bunch of methods to turn it back into the dataset. One such function is the aggregation function. It accepts the expressions describing the columns you want the resultant dataset to contain In our case, we want the resultant dataset to have a year build column and the sale price average column. The year build column is present by default since we are grouping by it. We can add the average of the sale price as follows. The HG is the aggregation function. It accepts the columns to be included in the resultant dataset. AVG is the average function, which is present in scope due to the SQL.functions import in the beginning of the notebook. This one. Average, as the majority of other statistical functions, takes the name of the column and performs a computation on it. In this case, it returns a new column with the average of the elements of the given one. Now we have the following dataset, perfect for the visualization as the line chart. The next step is to visualize it. We can do it by constructing the line chart object and returning it from the cell, as follows. Line chart is a case class. When it is returned from the cell, that is, you put it as the last statement of a cell, SprkNotbuk renders the chart. The first argument of the object is the dataset we want to visualize. Notice that we sorted by year, otherwise the order of the elements of the x-axis is not guaranteed. The other widgets are implemented similarly. Another useful chart is a pie chart. It is useful to visualize the total fraction some element has in the entire dataset. Another question we can ask about our dataset is which neighborhood of the city is the most promising one in terms of houses and their prices. In other words, if we sum all the prices of the houses in a given neighborhood, which one's sum is the largest? We can visualize this via a pie chart, where each slice represents a neighborhood and its arc length is proportional to the total price of the houses in this neighborhood. First, we prepare the data for visualization. We need a dataset with a column representing the neighborhood and another column with the sum of the prices of the houses from that neighborhood. We can do it similarly to how we prepared the data for the line chart. Then we can visualize this via pie chart as follows. You can hover the mouse over the slices to get the numeric values of them. Apparently, North Ames has the greatest amount of money in houses. Next chart we will have a look at is radar chart. It is useful for comparison of small amount of elements of a dataset according to multiple criteria. For example, let us compare the first two houses in our dataset according to the number of bathrooms they have. First, let us select the columns we need to compare. We can find the columns with the number of bathrooms of various types in the specification of the data. Next, we can visualize that with a radar chart as follows. Note that we need to specify the label field constructor argument to specify which column in our dataset is the label. Note that we need to specify the label field constructor argument to specify which column in our dataset is the label. We can see it displayed when we hover the mouse over the plot, as follows. Also note that it is hard to compare large amounts of elements this way because they overlap. These and other widgets are the part of SprkNotbuk. You can find the documentation on how to use them on SprkNotbuk's GitHub page. All the other widgets are used similarly to the ones we have covered. It is also possible to parameterize them via constructor arguments. You can find the arguments for each widget and their default values in the documentation. You can see the links to the documentation on this slide. Also, it is worth mentioning that these charts are implemented internally using JavaScript, so it is possible to extend the library with the new plot types similarly to the ones that it already has.